In Lesson 8, we're going to start talking about the idea of variability in a data distribution. For example 1, it's asking us to compare two distributions. So Robert's family is planning to move to either New York City or San Francisco. Robert has a cousin in San Francisco and asked her how she likes living in a climate as warm as San Francisco. She replied that it doesn't get very warm in San Francisco. He was surprised, and since temperature was one of the criteria he was going to use to form his opinion about where to move, he decided to investigate the temperature distributions for New York City and San Francisco. The table below gives average temperatures in degrees Fahrenheit for each month for the two cities. So you'll see that they have listed New York City and San Francisco. Across the board, they show the temperature average temperatures for each month. And we're going to look at these two to figure out where he should move. So we're going to start by finding the mean temperature for each city. So remember, to find the mean, we're going to add data together and divide by number of data pieces. Okay, so we're going to take each of the numbers from New York City and add them together. You can either list them out or just kind of put plus signs here in between each to show that you're adding those. And then I'm going to write just the total down at this point. If I were adding all of those across, I would get a total of 756. And then I would divide by the number of numbers that I added together. And if you know how many months are in a year, you would be dividing by 12. So when I divide by 12, I get 63 degrees as an average annual temperature. If I do the same thing for San Francisco, add all of those together, I end up with 768, which I then again divide by 12, and this time I get 64 degrees. So 63 degrees and 64 degrees aren't really that different. If you walked outside on a day where it was 63 degrees and then a day where it was 64 degrees, you probably wouldn't be able to tell much difference as long as the other weather things were all the same. So if it was cloudy on both days, you wouldn't be able to tell the difference. So in number 2, it says, recall that Robert is trying to decide to which city he wants to move. What is your advice to him based on comparing the overall annual mean monthly temperatures of these two cities? So if we're just specifically looking at the mean, there really is no difference between these two temperatures. So based on the mean, he could move to either. Okay, so the mean temperature doesn't really give us a good indication of temperatures. Example 2 talks about variability. In number 2, you found the overall mean monthly temperatures in both the New York City distribution and the San Francisco distributions to be about the same. That didn't help Robert very much in making a decision between the two cities. Since the mean monthly temperatures are about the same, should Robert just toss a coin to make his decision? Is there anything else Robert could look at in comparing the two distributions? Variability was introduced in an earlier lesson. Variability is used in statistics to describe how spread out the data in a distribution are from some focal point in the distribution, such as the mean. Maybe Robert should look at how spread out the New York City monthly temperature data are from its mean and how spread out the San Francisco monthly temperature data are from its mean. To compare the variability of monthly temperatures between the two cities, it may be helpful to look at dot plots. The dot plots for the monthly temperature distributions for New York City and San Francisco follow. So you'll notice that we have New York City over here with all of our dots, the 12 dots for each of the months, and the same thing for San Francisco. Mark the location of the mean on each distribution with the balancing triangle symbol. How do the two distributions compare based on their means? Now, we've kind of already talked about this. So the 63 would go about here for New York City, 64 would go here for San Francisco. So based on their means, the means were about the same. 63, 64 are not very far off. So means are about the same. Describe the variability of the New York City monthly temperatures from the mean of the New York City temperatures. So what this is saying is, here's our mean. What can we say about how far spread out in either directions the mean or the temperatures are from the mean? So variability, again, is talking about how spread out the data is. So in New York City, they're spread out, and we usually talk about how they range. So they range from 39 degrees to 85 degrees, which I think we all know it gets colder than 39 and higher than 85 being from the New York area, but this is, again, just average. So now in number 5, it's saying describe the variability or how spread out San Francisco monthly temperatures are from the mean of San Francisco monthly temperatures. If you look, in talking in terms of spread out, these dots are spread out from this number. These dots are much closer or clustered together to the mean. So in this case, we say that they are clustered around the mean, clustered, clumped, clustered together around the mean, and they range from 57 to 70 degrees. Okay, so these were more spread out. I forgot to add that piece in here. Spread out, and they range from 39 to 85, whereas in San Francisco, they're more clustered together around the mean, and they range from 57 to 70 degrees. So the next piece asks to compare the amount of variability in the two distributions. Is the variability about the same, or is it different? If different, which monthly temperature distribution has more variability? Explain. So as we've kind of said walking through these problems, New York City is much more spread out than San Francisco is. So their variability is different. They're differently spread out. So which monthly temperature distribution has more variability? More variability means it's more spread out. So New York City has more variability, more spread out. The temperatures range more. If Robert prefers to choose the city where the temperatures vary the least from month to month, which city should he choose? Explain. Well, if he wants to go where they don't change too much, he would want to stick to San Francisco. San Francisco temperatures have less variability. They don't spread out. There's not like a wide range of temperatures. They're much more clustered together. It's more likely to step outside and have it feel the same on any single day of the year, as in, if you know, coming from New York, if you step outside one day in the winter, it's going to change a lot from stepping out one day in the summer. Okay, so that's kind of that idea of variability, how far spread out data is. Now, example 3 is asking us to use the mean and variability in a data distribution. So the mean is used to describe the typical value for the entire distribution. Sabina asks Robert which city he thinks has the better climate. He responds that they both have about the same mean, but the mean is a better measure or a more precise measure of a typical monthly temperature for San Francisco than it is for New York City. She's confused and asks him to explain what he means by this statement. Robert says that the mean of 63 degrees in New York City, 64 in San Francisco, can be interpreted as the typical monthly temperature or the typical temperature for any month in the distribution. So 63 or 64 should represent all of the month's temperatures fairly closely. However, the temperatures in New York City in the winter months are in the 40s and in the summer months are in the 80s. The mean of 63 isn't too close to those temperatures. Therefore, the mean is not a good indicator of typical monthly temperature. The mean is a much better indicator of the typical monthly temperature in San Francisco because the variability of the temperatures there is much smaller. Consider the following two distributions of times it takes 6 students to get to school in the morning and to go home from school in the afternoon. To visualize the means and variability, draw dot plots for the two distributions. So we've got morning, we've got 11 minutes, 12 minutes, 2 14 minutes, a 16 and a 17. For the afternoon, we have 6 minutes, 10 minutes, 13 minutes, 2 18s, and a 19. What is the mean time to get from home to school in the morning for these 6 students? So we would be doing 11 plus 12 plus 14 plus 14 plus 16 plus 17. So we're taking our total. And in this case, our total is 84. And then we're going to take our 84 and divide it by the 1, 2, 3, 4, 5, 6 students. So we'll do our 84 divided by 6 and get 14. So the mean time is 14 minutes for the morning. So for the afternoon, we'll take 6 plus 10 plus 13 plus 18 plus 18 plus 19. I'm going to use my calculator. To get 84 as well. 84 divided by 6 is 14. So they both have a mean of 14. For which distribution does the mean give a much more precise indicator of a typical value? Explain your answer. So we want, in this case, the one that has less variability. So whenever they're asking us which one is where the mean is a more precise indicator of a typical value, or the mean is more of a typical value, it's the one where it's spread out the least, where those times or those temperatures or that data is closer to the mean than in the other one. So from looking at these two pictures, hopefully you can see in the morning, those temperatures are nice and close, or not the temperature, excuse me, the times are much more closer together. Whereas over here, our mean is right here, but our temperatures are fairly spread out from that based on the difference between the morning. So in this case, the morning is a better indicator of a typical value. I spelled morning wrong. Because it has less variability, less spread out from that mean.